Morning, this is Kasturi Day. Today I am going to continue with the discussion of the heat transfer chapter according to ICSE syllabus class 8. Okay, so in my last two videos I started with the discussion on that introduction, then effects of heat, then how the liquid changed into vapor state, liquid state changed into vapor state. It's a continuation of that topic. So I was discussing about the evaporation, the effects of heat on the evaporation, on the liquid state. Okay. So there are two ways in which the liquid state changed into vapor. That is, one is evaporation, another is boiling. Then what is evaporation? I discussed or told you what is evaporation, and then how the evaporation process is explained by the molecular motions, and then the rate of evaporation depends on what? The temperature, wind, then surface area, presence of humidity. And then I've come to discuss on the cooling which is produced by evaporation. Then we have come to boiling. So that boiling, I'll discuss today what are the effects of pressure on the boiling point. Where for boiling there is a fixed temperature. At fixed temperature the liquid starts boiling. Okay, but evaporation can happen at any temperature below the boiling point of the liquid. So BP, that is boiling point, is directly proportional to pressure. That is, boiling point increases with the increase in pressure and boiling point decreases with the decrease in pressure. Okay, the reason is that at the boiling point the pressure exerted by the vapor of the liquid is equal to the atmospheric pressure. Okay, so what happens at the boiling point? The pressure which is exerted by the vapor on the liquid, the vapor, we know that when the boiling point comes of any boiling point of the liquid, any liquid, the liquid starts changing into vapor, and that vapor creates an exerts an pressure, and that is equal to the atmospheric pressure. With the increase in the atmospheric pressure, boiling point of the liquid also increases, and so the vapor pressure increases, and therefore the vapor pressure increases, and which make it equal to the atmospheric pressure. Okay, and with the decrease in the atmospheric pressure it decreases. So at the mountains, what happens, the atmospheric pressure is low, we know that, and for that reason we use when we go to the mountains, we need a pressure cooker to cook the vegetables. Why? Because water boils at very low temperature than the 100 degrees centigrade. Water generally boils, water's boiling point is 100 degrees centigrade, but when we go at the mountains, then what happens, the pressure, the boiling point falls due to the atmospheric pressure which is low there. So pressure cooker is used, and to what happens when we use a pressure cooker, we increase the pressure. Okay, increase the pressure and of the vapor, and that increases the boiling point of the water, which helps to cook the vegetables better. Okay, so there the boiling point becomes 125 degree centigrade when we cook it in a pressure cooker. Then see the difference between boiling and evaporation. Okay, now liquid changes to vapor at a constant temperature in boiling, but in evaporation liquid changes to vapor at any temperature which is below the boiling point. For boiling, an external source of heat energy is needed. For evaporation, it does not require any external source of heat. It absorbs the heat from the surroundings. Okay, so boiling, it's a bulk process where the gaseous state is formed from all parts of the liquid, and there is an agitation in the liquid which is formed. Okay, that is, the whole of the liquid starts boiling, and all the molecules in the liquid colliding with each other very fast. That's why it's a there's an agitation in the liquid and it's a bulk process. Where in evaporation, it's not a bulk process, and gaseous state is formed from only the exposed surface of the liquid. It's a surface phenomena. That is, the liquid evaporates only from the surface. Okay, the boiling does not cause cooling, but evaporation causes cooling because it absorbs the heat from the surroundings. And so what happens when evaporation takes place, the surrounding becomes cool. The boiling indicates the strength of the intermolecular forces between the molecules of the liquid. But evaporation, it's a spontaneous phenomenon, so it does not indicate any such strength. Because in boiling, it's a very rapid process, no? So we can understand that we can understand that what the intermolecular forces are changing, because intermolecular forces in the liquid is not so not so weak than in the gases, than the vapor state. So what happens in the, it's a very, when the liquid changes into vapor, the intermolecular forces become very weak. Okay, and so we can understand, we can identify this change. But in this evaporation, so as it is a spontaneous phenomenon, we will not be able to understand this change. Okay, it's a rapid process. Boiling is a rapid process, whereas evaporation is a slowing process. Whereas boiling, heat is supplied externally at a fixed temperature, whereas in evaporation, it is absorbed by the molecules at the surface of the liquid from its surroundings to change it into vapor. Okay, next is thermal expansion. Okay, so it has been extremely experimentally proved that solid, liquids and gases expand on heating and contract on cooling. In solids, the solids which have a definite shape, but when it is heated, it expands in all directions. Okay, it expands in length, it expands in area, it expands in volume. Then increase in length of the solid is known as linear expansion, increase in area of the solid is known as superficial expansion, and increase in volume of the solid is cubical expansion. Okay, then explanation on the basis of the molecular motion. When a solid is heated, what happens? The average kinetic energy of the molecules of the solid, that becomes that increases. Okay, when the solid is heated, the molecules, they, when the in original condition, the solid molecules, they are moving in a fixed position. But when it is heated, the average kinetic energy of the molecules of the solid increases, and they start about their mean position with a greater amplitude. Okay, so their mean position change and their intermolecular spaces increase, which decreases their intermolecular force of attraction, and so the solid expands in all directions. Then linear expansion. When a solid in the form of a rod or a wire is heated, then the linear expansion occurs. That is, it increases in length. Okay, it depends on three factors. That is, original length of the rod or wire, its increase in temperature, how much the temperature is increased, and the material of the rod or the wire. Okay. Next is original length of the rod. When two rods of the same metal are heated, okay, to the same temperature. Okay, same metal, same temperature, two rods. One is short, one is long. The height difference, the length is different. Metal is same, temperature is same, only the length of the two rods are different. That is, one is short and one is long. It's found that the long rod expands more than the shorter one, and so longer the rod, greater is the increase in length. Okay. Next we come to increase in temperature. When two rods of the same metal and same length, okay, length is same, metal is same, but temperature is different. One is at higher temperature, one is heated to a higher temperature, and other to a lesser temperature. Okay, so what happens? It's found that the rod which is heated to a higher temperature expands more than the rod which is heated to a lower temperature. So more the increase in temperature of the rod, greater is the increase in length. Okay, next is material of the rod. Now if two rods of the same length are heated, same temperature, same length, same temperature, but one is of copper and other is of iron. It's found that copper rod expands more than the iron rod. Nearly it's 3 by 2 times. 3 by 2 times the length of the iron rod. Okay. So the increase in length of the rod depends on the material of the rod. Okay. So it is an increase in length of the rod depends on the material of the rod. Now, coefficient of linear expansion. What is coefficient of linear expansion? When L0, if L0 is the length of the rod at 0 degrees centigrade and LT is the rod of the length of the rod at T degrees centigrade. So, increase in length will be LT minus L0. That will be equal to LT alpha T. And what is alpha? Alpha is the coefficient of linear expansion which depends on the material of the rod and is different for different substances. And that unit is degrees centigrade. Okay. So alpha is the coefficient of linear expansion. So for the coefficient of linear expansion, we need to, there's a formula that is LT minus L0 is equal to L0 alpha T. Next is different metals have different coefficients of linear expansion. Like aluminium, its coefficient is coefficient of linear expansion is 24 into 10 to the power minus 6 degrees centigrade. Okay. Brass, that is 19 into 10 to the power minus 6 degrees centigrade. Copper, 17 into 10 to the power minus 6 degrees centigrade. Steel is 13 into 10 to the power minus 6 degrees centigrade. Iron is 12 into 10 to the power minus 6 degrees centigrade. And Invar is 0.9 into 10 to the power minus 6 degree centigrade. Okay. Now, Invar, it's an alloy. It does not expand on heating. So, it is used in the pendulum of a clock. And Pyrex glass, it expands negligibly on heating. Okay. Next, it's a superficial expansion of the solids. Okay. For this superficial expansion, when a metal is heated, metal plate is heated, its length and breadth both increases. So the area of the plate increases. Okay. So I'll continue with this discussion, this superficial expansion in my next video. Please go through this. If you have any doubt, please do let me know. Write in the comment box. And I hope you are liking the videos. And please do press the like button and also do subscribe to get the notification of my next video. And please do wait for my website to be launched. Okay, I've told you in my last few videos that I'll be launching a website, so please wait for that. It will contain much more information of your subjects as well as some different subjects, also general knowledge facts, and some more interesting things are there. So and thank you for watching.